All right, so again, this is the current composition of the Earth's atmosphere. We have 78% nitrogen. It's the N2 molecule. It's 21% oxygen. The O2 molecule that we need to breathe. In the upper atmosphere, in the stratosphere, is the ozone. That's the O3 molecule. Notice these over here, including water and carbon dioxide and ozone, are variable gases. That is, they vary. The amount of them varies, and we'll talk a lot more about that in chapter 25. So to a much less extent, the more permanent stuff is argon. There's less than 1%. There's a little bit of neon, a tiny amount of helium. There's methane, and of course, there's a little bit of hydrogen. Just keep in mind, the hydrogen cannot stay permanently in the atmosphere. It's just temporarily in the atmosphere. That should actually be a variable one. All right, let's move on to the next one. All right, so these are the different layers of the Earth. So we live in what's called the troposphere or the troposphere. You can pronounce it either way. Then comes the stratosphere. So the troposphere, by the way, has about 90% of all the air there is, and then above that is the stratosphere and the mesosphere. Then comes what's called the thermosphere, and then the ionosphere. We'll talk about each of these. And then you're truly in space when you get to the exosphere. So that's the first, the thermosphere is actually kind of where most satellites exist in the thermosphere. Low. So this would be like considered low Earth orbit. So stuff that goes around the Earth is usually in the thermosphere. All right. So if you truly want to be outside of the Earth, the vast majority of air molecules, you're in the exosphere. So this is truly, you're in space. So this is like 1,000 kilometers up. All right. So first of all, the one thing that I should mention is the entire atmosphere is a very thin thing, right? I mean, the Earth. Here, let's see. Do we have a picture of? No. The Earth is this 8,000 kilometer in diameter, roughly. And you go up 100 kilometers and you're up here, up above the mesosphere, right? So you're above most of the material, the stuff that is our atmosphere. Okay, so the atmosphere is extremely thin. All right, so the lowest part, so the troposphere is the lowest part. It goes up almost 20 kilometers above the surface of the Earth. And again, about 90% of the atmosphere is there. That's where all the weather takes place. That's where all the clouds are. Even really, really high clouds, which we'll talk about a little bit later in a different chapter. So the key thing about the troposphere is that the temperature decreases with altitude. So it goes down on average by about 6 degrees Celsius per kilometer that you go up. And when you get to the top of it, the troposphere is sitting at about -50 Celsius. All right, and then it's kind of an interesting thing happens. Just the opposite. It begins to warm up. It goes from 50, but it doesn't warm up like in a nice cozy way. It goes from -50 to 0 in this next thing called the stratosphere. All right, so this is where you're going to find the ozone layer. So the stratosphere goes anywhere from about 20 kilometers up to roughly 50 kilometers above the surface of the Earth. Right, so that's our stratosphere, and then of course that's where you find the ozone, the O3 layer, and the O3 layer, the ozone layer, it absorbs ultraviolet radiation, which is very, very harmful to most forms of life. All right, so the temperature does increase. As you know, and the ozone absorbs this ultraviolet radiation, and that causes an increase in temperature. But that eventually stops when you get to the top of the troposphere. When you get to the top of the stratosphere, and then you're in the mesosphere. So the mesosphere, now the bottom of the mesosphere is at 0 degrees Celsius, and then it starts getting cold again. You get up to, or down to, I should say, negative 90 degrees Celsius at the top of the mesosphere. Right. So this goes from the top of the top of the stratosphere to oops, I'm going the wrong way. Up to about 80 kilometers above the surface. So that's the mesosphere. So the temperature is now going down again, and the gases. So there's no ultraviolet. There's no. There is ultraviolet, but there's no ozone where the mesosphere is, and so the temperature is decreasing. As you go up higher and higher, and that's because this ultraviolet radiation is not being absorbed. Right. So then comes what's called the thermosphere. The temperature now is going to increase again. And remember, these increases are, they're a relative type of thing. Okay. So now, one thing I should bring up is temperature is a measurement of the average kinetic energy of the molecules that make up the gas, right? And so when we're talking about the atmosphere, we're talking about a gas, and the gas molecules are, much further apart than when they're in liquid form, and certainly a lot further apart than when they're in solid form. And so temperature is just a measurement of the speed of the molecules. And so in this thing called the thermosphere, you can have incredibly high temperatures. I mean, this is actually pretty high, 1500 degrees Celsius, but you're talking about only just a small number of particles, right? So it would be very, very cold overall. It would be extremely cold up there. I mean, you might run into a molecule that's really hot, 1 or 2, but it's still not gonna warm you up at all in the thermosphere. You don't want to be in the thermosphere. And then above the thermosphere is called the ionosphere, and this is a region. This is like where you see the auroras. The auroras are they're just charged particles that some of the charged particles come from the sun. They're part of what's called the solar wind, and those charged particles will follow the magnetic field lines, which extend way out beyond the atmosphere for the Earth anyway. So the Earth has its own magnetic field. Of course, we talked about that before, and these charged particles get trapped in the magnetic field and will crash into the atmosphere in this region called the ionosphere. And what happens is when these particles crash into the Earth's atmosphere in the thermosphere, they will excite the particles that are there, and they give off light, and it kind of like you can just look on YouTube and type in aurora. Sometimes it's called the aurora borealis. That's the ones that happen in the northern hemisphere, and above the North Pole. And then there's the aurora australis in the near the South Pole. And so these are just lights, these shimmering lights that happen just because charged particles are hitting the upper atmosphere. And then you get above the ionosphere. Oh, the other thing about the ionosphere, although people don't really worry about this so much anymore, but there was a time, for example, when you tuned a radio, and I know that's kind of a crazy idea. People used to tune the radio in their cars to the AM band. I mean, there's still some radio stations in the AM band, but what the thing about the AM band is it will bounce off of the ionosphere, depending on what exactly is going on there. And so there are times when people had like ham radios. That was a very popular thing, back in the 1950s and 60s. Not so popular anymore, but you could bounce a radio signal off the ionosphere and talk to people on the other side of the Earth. I mean, I know nowadays, of course, you just open up your computer or your phone, and you can communicate with people on the other side of the Earth. But that was a novelty back in the 1950s and 60s, and that was kind of a cool thing to do. So above the ionosphere is this thing called the exosphere. So you're actually in space beyond about 500 kilometers above the Earth. All right. So there's very few molecules that you're going to encounter there. All right. So this is just kind of a showing you in terms of temperature. So in the troposphere, the temperature is going down, right? So this is going down. And then when you get into the stratosphere, it goes down a little bit. And when you get up to 20,000, 20 kilometers. And then it, remember the troposphere, this is 90% of the atmosphere, 90% of the molecules. So the rest of this up to here is about 10% of the molecules that make up of the atmosphere. This in the stratosphere, of course, this is where the ozone is. And so what happens is you're capturing some of the ultraviolet light, or most of the ultraviolet light. A little bit of it does make it through the troposphere, by the way, but most of it gets trapped up here, and so that's warming up the stratosphere. And then this distinction between the stratosphere and the mesosphere is really is based on temperature. When the temperature starts going down again, you're in the mesosphere, right? And then the temperature starts going up again. It goes up very dramatically in a nonlinear manner. That's the thermosphere. But as we mentioned before, up here there's hardly any particles at all, and so way up here, it would be unbelievably cold. You might run into one or two particles that are at 1500 Celsius, but that's not going to warm you. And then of course you're in space, and most of the particles are well beneath you. And all right, so that's a nice view of this. And the let's see. So what was I going to say? Let me go back for just a second. So that's that. Ozone. Okay, so I covered everything. Radiation. Yes. Thermosphere. All right, talked about that. The ionosphere. Okay, so yeah, it's not really showing it. The ionosphere is here. Let's see. What does it give us with the anyhow? So the ionosphere is above the thermosphere. Oops. Let's go this way. So it's just slightly. It's a very narrow layer of the atmosphere. At any rate, that's where I mean, why it's called the ionosphere is because they're charged particles. The